lesson is on limiting reagents. You know that you have a limiting reagent problem when you are given the initial amounts of more than one reactant. You can't assume that you have stoichiometric amounts of reactants present, so you have to determine which reactant is going to limit the amount of product that can be formed. Hence the alternative title for this presentation, Having Twice as Much Fun by Doing Twice as Much Math. We're going to be using paper clips as models for atoms and molecules. So just imagine that we're starting with an equal number of hydrogen atoms and oxygen atoms. So for example, if you wanted to have 8 hydrogen and 8 oxygen atoms, you could have 8 blue paper clips and 8 red paper clips. We know that hydrogen and oxygen are both diatomic, so we're going to assemble them into paperclip molecules. So we're going to allow the reaction to happen. So we're going to make our product molecules by taking the hydrogen and oxygen apart and recombining them to make the water molecule, paperclip water molecules. You continue to do that, making a water molecule each time. Until the reaction finally stops. And the reason why it stops after forming 4 paperclip water molecules is because there aren't any more hydrogen molecules left to react. So the reaction is limited by the amount of hydrogen initially present. Therefore, hydrogen is a limiting reagent. It limits how much product you can make. So here we have the paperclip molecules again. And we have, I changed it to 3 just to make the numbers a little bit different. And we're trying to figure out how many grams of water will we actually form. So instead of talking about individual water molecules, let's change that to moles. And we're going to make the assumption that all of the hydrogen reacts. We're going to ignore the presence of the oxygen. So you go through and you say, all right, well, 3 moles of hydrogen. We have a 2 to 2 relationship. So therefore, if all of the hydrogen reacts, it will make 3 moles of water. Do the same thing for the oxygen. So we're starting out with 3 moles of oxygen. This is a 1 to 2 relationship. So therefore, if all of the oxygen reacts and we're ignoring the hydrogen, it would make 6 moles of water. Now you can't make something out of nothing, so that means that we are not going to make 6 moles of water. We're going to cross that out instead, so we don't forget that that is not reasonable. We're actually only going to make 3 moles of water. You can determine the limiting reagent by tracing those arrows backwards, and you see that hydrogen is the one that didn't get crossed out, so hydrogen was a limiting reagent. If you want to find the number of grams of water that will be formed, we're going to take our smaller number of moles of water and multiply by the molar mass. And we get that 54 grams of water will actually be formed. And you'll be left over with some oxygen gas. Or you'll have some oxygen gas left over. So here we have a mole-to-mole stoichiometric relationship. So write down what you know. We have 1.55 moles of hydrogen gas. It's a 2 to 2 relationship, so therefore that would make 1.55 moles of water. And we have 0.3 moles of oxygen. This is a 1 to 2, so we're going to multiply our 0.3 by 2, and that would be 0.6 moles of water. We cross out the larger one. The one we didn't cross out is the oxygen. You just trace it backwards. So that is the limiting reagent. And hydrogen would be the one that is in excess. You're going to have some hydrogen left over. Now that we know which one is the limiting reagent, we know how many moles we're actually going to make, we can now figure out how many grams of water we can make, because you can't do anything directly with moles. So it'll be 0.6 moles of water times its molar mass, and you get that 10.8 grams of water will actually form. So here is a complete stoichiometric conversion. We're going from grams to grams, but we still know that it is a limiting reagent because it gives us grams of hydrogen and it gives us grams of oxygen. So we have to figure out which one is going to limit the amount of product. So you set up your stoichiometry chart, write down what you know, and we're trying to get to grams of water, which is why I have this yellow box. Next step, we're going to do our GFM, our molar mass. Now we're going to find our moles. One of the reasons why I like setting it up in a stoichiometry chart is because the numbers are in perfect position, so you can just go the grams divided by the molar mass. That gives you the moles. So now we're going to do our conversions. 2 to 2 relationship, so therefore the hydrogen will make 0.58 moles. Do the same thing with oxygen. I have it color-coded, but most of the time people just end up using arrows in order to connect the different numbers together. So we end up having 0.23 moles of oxygen are present. It's a 1 to 2. So that means it would only be 0.46 moles of water will be formed. Cross out the bigger one. So that means oxygen is our limiting reagent. And now that we know how many moles of product will actually be formed, we can go ahead and finish the calculation. Find the number of grams of water by going moles times the molar mass of water. And it gives us 8.29 grams of water actually formed. And so the worksheet that goes with this consists of a bunch of different limiting reagent problems. And just to explain it, I have your initial numbers of grams of oxygen and grams of aluminum, and I have one of the products underlined. My thinking was that if you can figure out how many grams of product for one product, you can do it for the other one. So we're just trying to save on a little bit of math. All right, so the next line in the stoichiometry chart is your GFM. So the GFM of oxygen is 31.999. I don't know why I don't just write down 32. And aluminum is 26.982. Now we got to figure out our moles. So our moles of oxygen works out to be 0.13. And the moles of aluminum are 0.154. I should say that was a 0. All right, so since I'm already here, I'm going to go ahead and do my arrows right now. This is a 4 to 2 relationship. So I'm going to take my 1.154 and divide by 2. So that would give me 0.077 moles of aluminum oxide would be formed if all of the aluminum reacts. And then we're going to go all the way over here. Notice how I'm connecting these things with arrows. So we have a 3x to 2x. So the first thing we want to do is find out what 1x, so one equivalent would be. So we're going to divide by 3. And then that gives us what one equivalent is, or 1x. So therefore, we're going to multiply by 2 so that we can get the appropriate number of moles for aluminum oxide. And that works out to be 0.087. All right, we've done our conversions. We're going to cross out the bigger one. The limiting reagent is the one we didn't cross out, so we trace it backwards. So our limiting reagent is going to be the aluminum. Now we're ready to find our number of grams of aluminum oxide that are actually formed. The GFM for aluminum oxide is 101.962. To give us 7.85 grams of aluminum oxide will actually be formed. All right, so go ahead and try your hand at the other problems on the worksheet, and thanks for listening. Bye.